Well, let's talk to one right now. I'd like to invite Prakash to stage and talk about real life here, and maybe even have a surprise for you. So,
Absolutely. Prakash.
thank you. Yeah. So let's talk about Cropin and what you're doing, and specifically, what's the scale of the problem you're trying to solve?
Cropin operates one of the world's largest AI platform deployed in food and agri sector, and with the vision of making global food system more intelligent, resilient, and sustainable. And recently, we computed 1 billion acres of land worldwide, spanning across 102 countries. And we also digitally collected 9 million farmers' data and deployed 20 plus crop science and transformer models for 500 plus crops globally. Just to give you an idea of the scale, the 1 billion acres of land accounts for 10% of the world agricultural land. Right? So that's the scale which we operate. What we do is we process this data in planetary scale, then we analyze and convert this data into actionable insights so that it can be used by farmers, agronomists, food companies, governments, financial institutions to make the very interesting decisions and actionable decisions in the food and agri sector. Right?
Nice. What tech stack do you need to make that happen? What do you depend on?
In a very layman terms, you can take any piece of land in anywhere in the world, right? And our platform can figure out what is growing there, how is it progressing, and what has been the yield. Is there any water stress? Is there any upcoming diseases? And finally, what is the forecast for the yield and the harvest cycle?
Yeah.
And we can do all of these without visiting a farm, right? So magic, isn't it? Right? How do we do, right? The backbone of our platform is the Google Cloud, right? So that's been the foundation layer, right? And so what we do is that internally we call it as a data hub. In data hub, we put a proprietary intelligence layer, right? Which is the collection of the data and the model what we run and the geospatial data what we store, the climate data, soil data, IoT data, all the field data what we collect, we store in this data store. And then we have something called a living digital layer, and we call it as a grid, right? So just to give you an idea, a grid can vary from a 10 by 10 meter to 5 by 5 kilometer, right? 5 kilometer width, 5 kilometer length, right? So, and accounts for roughly 2,500 hectares of land, right? And more closer you go to North Pole, it starts from 2,400, and if you're far away from the North Pole, it can go up to 2,550 hectares, right? And we have this digital layer. We marry this digital layer with different set of data parameter. It can be geospatial imageries, weather data, and disease data, crop health monitoring. Then we have models deployed on top of this data. It can be a crop science model, or it can be transformer model, and the past seasonal histories. Then we run the yield model, right, and the growth stage monitoring, just to give a sense of the data which we operate, right? So if I divide the whole Earth into the different pieces of 5 by 5 grids, right? So it'll account for roughly 2 million, close to 2 million grids, right? And we processed around 200K grids, which is 1 billion acres of land, which is 10% of the world agricultural land, right? So, and that's where we process. And how do we operate? To answer your question, this is how we structure the data in the grid, and we store in our data lake, which is powered by BigQuery.
Great.
Right? And BigQuery has been our foundation layer for how we scale, how we compute, and how we efficiently query the data, right? And on top of this, we also have Google Earth Engine, where we process the planet scale imageries for the remote sensing and the images from the different satellite. It can be Sentinel, it can be Landsat of the world, or the paid satellite like Planet Labs we directly connect. And then we have a Weather Next APIs, which is from Google to get the weather APIs from the different resolutions. Then on top of this, we use Gemini for the language reasoning. And we also marry this with the ADK platform so that user questions can be identified and answered in the very simplistic term, and so that right actionable results can be shared with the user.
Love it. I think we have a minute left, but give me the announcement. What are you ready to share with the audience here today?
Yeah. In our typical agentic world, there'll be a couple of problems. One is remote, the data of the agriculture is very, very local, right? And it changes in the real time, right? And what happened last year it's not going to affect what happens today, right? So, and the decision what a farmer can make has to be depends on what is the current ground conditions. It can be soil health, it can be weather conditions, or how the crop has been progressing, what are the upcoming disease today, right? The other factors which matters a lot is the timing, right? So if I get a disease alert, right? If I get 1 day late, so probably half the farm is already damaged, right? The timing matters a lot. And at the same time, to deliver these results in a very fast, in a real time, needs a very highly efficient compute storage and the processing. That's where we use the Google Stack, right?
All right, we have about 10 seconds left, so you gotta
Yeah.
show everybody what they can try here.
Yeah. What has been the problem is that we have been working on the platform we have been building this platform over the years, right? And we collected this data, and we wanted to democratize this, and we wanted to make it as simple as searching a location in Google Map, booking a cab using Uber, right? So, and that is exactly what we built. We are trying to announce the OrbitAI, right? World first native domain trained platform deployed for food and agriculture, right? And here's a quick glimpse of it. These are the different personas: farmers, agronomists. A farmer is asking questions that ask OrbitAI about the satellite imagery. I want to monitor my farm. And here is the drop boundary. We call it as area audit. So boundary is selected. So now I'm giving the next set of details. It can be plot name, sowing dates. Plot is saved. Now the farmer is selecting the objectives. He wants to monitor the health, weather, disease, extreme events, field level actions. The plot is added. Let's say a farmer use case. He's going to ask the question, what is my current week looks like? What do I have to do? Right? So it's giving a data is like the 9 plots needs attention, and here are the splits of the plots which needs this attention. And the next user is the agronomist. Typically, agronomist works with the farmer and try to give a diagnosis for the farmer based on the field conditions and weather conditions and so on and so forth. And here, the farmland which he's looking at is a 20% more greenness, 90% more stress, and 2 plots are highest risk, 2 are moderate, 6 are. So next is the sourcing lead. Typical sourcing lead persona is going to be, they operate in the regional level. So here is the example of a sourcing lead who would like to procure paddy in Karnataka, right? So he would look into what are the different paddy growing regions, and how do he minimize the sourcing risk, right? So which part of the area which he has to focus, which is under more disease risk, right? So it's giving a suggestion that the Mysore belt has the best, and he can go and procure the paddy from there, right?
All right, let's jump to people can try this out.
Yes. So it's very easy. You can scan your QR code. We are officially launching today. You can also access from orbitai.cropin.com, and it's completely free, built in India, and all models powered. We use Gemini for the language reasoning, and this is built from the data we collect from the last decades, and over 9 million farmers, as well as the 1 billion compute what we have done. Yeah.
Amazing.
Thanks a lot.
Thank you. So, talked a lot about production-grade AI, how we work with AI, how we build agents, saw examples. Hopefully the biggest takeaway is start trying some of these things out, these practices, these tools, and real-life examples. So thank you. I'll see you the rest of the